Welcome, friends. I'm Professor Andrii Bondarenko, and on this channel, we unpack the power, mechanics, and science behind heavy industrial machinery. I'm glad to be your guide through the engineering marvels that shape our modern technogenic world. Today, we are taking a deep dive into earth-moving machinery. According to international standards, earth-moving machinery is defined as a self-propelled or towered machine on wheels or trucks, equipped with the attachments primarily designed to perform excavation, loading, transportation, spreading, compacting, or trenching of earth, rock, and other materials. Earth-moving machinery refers to machines in which the movement of the working attachment for soil extraction and transportation is achieved through the movement of the machine as a whole. This machinery consists of base tractors, prime movers, or custom chassis fitted with the mounted trailed or semi-trailed working attachments. Key examples include bulldozers, reapers, scrapers, motor graders, and front-end loaders. Let's briefly review the design, purpose, working principle, and applications of these earth-moving machines. Among them, bulldozers are the most widely used. These industrial units are frequently deployed in open-pit mines, construction sites, road works, and similar operations. A bulldozer is a self-propelled crawler or wheeled machine equipped with a front-mounted blade used primarily to cut, move, and spread material through the forward motion of the vehicle. Bulldozers are classified according to several key engineering criteria: undercarriage type, rated engine power, blade design, and rear attachments. First, by undercarriage type, they are divided into crawler bulldozers, primarily used for heavy-duty excavation, mining, land clearing, and slip-slope operations; wheel bulldozer, used for surface cleanup in open-pit mines, stockpiling, and the maintenance of whole roads. Second, by engine power, bulldozers are categorized into compact, medium, heavy, and super heavy machines. Third, based on blade design, we distinguish straight, universal, semi-universal, angle, and power angle tilt blades. And finally, by rear attachments, they are classified as reaper equipped, winch equipped, or drawbar configured. By the way, modern bulldozers are even capable of operating in underwater conditions. For example, the Komatsu amphibious underwater bulldozer is capable of working at depth of up to 7 meters. This advanced industrial machine is controlled remotely via radio, cable, or a snorkel pipe system. These amphibious units are commonly used for riverbed clearance, coastal erosion control, port excavation, and bridge pier construction. Let's move on to another industrial machine commonly encountered in earth-moving operations. A reaper is a heavy-duty, rear-mounted tractor attachment equipped with one or more high-strength steel shanks designed to fracture, loosen, or break up hard soil, compacted strata, frozen ground, or semi-rocky formations prior to excavation or dozing. In most cases, when there is a need to break rock, compacted strata, or frozen ground, single-shank or multi-shank reapers are used. The design of single-shank unit is shown on this slide. For fracturing hard rock surfaces under difficult mining conditions, explosive-assisted reapers and hydropneumatic reapers are also utilized. The next earth-moving machines we describe here are front-end loaders. A front-end loader is a self-propelled earth-moving machine equipped with a front-mounted bucket operated by hydraulic lift arms. It is designed for scooping, lifting, transporting over short distances, and dumping bulk materials into haulage units or stockpiles. Front-end loaders are classified based on several key design and operational parameters. First, by undercarriage type, we divide them into wheeled and crawler loaders. Wheeled loaders offer high mobility and faster travel speeds, making them ideal for stockpiles and smooth quarry floors. Crawler loaders are optimal for soft ground, rough terrain, and heavy excavation. Second, by steering system for wheeled units, they feature articulated frames, rigid frames, or skid steer systems. Third, by discharge direction, they are classified as front discharge, side discharge, or rear discharge overhead loaders. Fourth, by engine power and operating weight, they range from mini and medium loaders to heavy quarry loaders, which feature engine power exceeding 250 kilowatt and bucket capacities up to 20 cubic meters for high bench mining. And finally, by drive system, we distinguish hydrodynamic, hydrostatic, and diesel-electric drives. Let's shift our attention to another industrial machine. A scraper is a heavy earth-moving machine equipped with an open-top bowl and a hydraulically operated cutting edge. It is designed to perform the complete cycle of earth-moving operations: digging, loading, transporting, dumping, and spreading material over medium transport distances, typically from 100 to 3,000 meters, without requiring separate loading or haulage equipment. Scrappers are classified based on several key design and operational parameters. First, by method of coupling or towing, they are divided into towed, also known as pull type, and self-propelled scrappers. Second, by engine and drive configuration, we distinguish single engine and dual engine models. Third, based on their loading mechanism, they are categorized as conventional push-loaded systems, elevating scrappers, or advanced push-pull systems. Fourth, by method of unloading or dumping, they utilize either forced ejector type unloading or semi-forced gravity dumping. And finally, by capacity and size, they are grouped into small, medium, and heavy classes. The next earth-moving machine we are going to cover today is the motor grader, also known as a road grader. This self-propelled machine features a long adjustable blade positioned between its front and rear axles. It is primarily designed for precision leveling, grading, shaping surfaces, creating slopes, and ditching in road construction, mining, and civil engineering projects. A motor grader uses a multi-axis blade assembly that can rotate and tilt to achieve precise surface contours and finish grading. The primary functions of motor graders include subgrade leveling and road base preparation, bank slope and ditch cutting and shoulder dressing, whole road maintenance in surface mining, material spreading, and light earthworks. Let's finish our today's lecture with an interesting fact about earth-moving machinery. Did you know that the largest production earth-moving machine of its kind is the Komatsu D575A superdozer? This outstanding industrial machine is used extensively in major open-pit mining operations. It features an operating weight of 152 metric tons, engine power exceeding 850 kilowatt, and a standard blade capacity of 69 cubic meters. Standing at a total height of nearly 5 meters, this superdozer is a true titan of modern engineering. Today's topic was dedicated to the power and mechanics of earth-moving machinery. I'm Professor Andrii Bondarenko, and on this channel, we unpack the power, mechanics, and science behind heavy industrial machinery. I am always glad to be a guide through the engineering marvels that shape our modern technogenic world. If you enjoyed this video, don't forget to hit the like button, subscribe to the channel, and share your thoughts in the comments below. If you have any questions about these machines, drop them down there. I'll be happy to respond. Thank you for watching, and I'll see you in the next episode as we continue exploring the secrets of heavy machinery.